This session is about responsible use of artificial intelligence in systematic reviews and evidence synthesis. We recommend people to use AI as much as they can, as long as they are responsible. And in this session, I'm going to give you an update on the progress of using AI and applying it in different stages of systematic reviews and evidence synthesis. Hopefully, you will find it useful, and hopefully it will encourage you to start using AI technologies. A bit of background from me. I'm evidence synthesis specialist, and I've been doing evidence synthesis and systematic reviews for now 22 years. And I've been using AI in parts of systematic reviews for over 15 years now. So here I'm going to share part of my experience with you as well. Just a bit of clarification about the terminology. You hear a lot about intelligence, like artificial intelligence, machine learning, cognition, computer cognition, neural networks, and hallucinations. These are the things that we usually use on human, but computer scientists were smart enough to advertise the technologies they have created by humanizing them. So when we are talking about the intelligence, learning, cognition, neural networks, and hallucinations, we are not referring in a way that it exists in humans, because the machines can do things by predictions and by following the algorithms, but they are not really intelligent, and they are not really learning or have cognition, and they are not really hallucinating. So the errors, we call them hallucinations sometimes. So it makes it easier to understand to people who are not computer scientists. But when we are talking about it, generally, we don't mean that the machines are intelligent. We don't have a better word. They are mimicking humans' characteristics. There are three myths about the AI that I think the clarification would help a lot. And I think if you just take this one slide with you, that should be quite enough from this session. I don't have high expectations. So one is that the AI is not new. It existed for a very long time, and we have been using a sort of AI called predictive or discriminative AI a lot, and currently are using it before 2020. So before 2020, when we were talking about the AI, we usually talked about machine learning. Machine learning is a way to achieve artificial intelligence, is one way to achieve artificial intelligence, not the only way. You may have heard that there was a review called Topol review, in which Topol, a cardiologist, American cardiologist, discusses that the AI is making such a good progress that it's going to replace dermatologists, pathologists, and radiologists initially, and later it will come for the other professions. And the reason is that we were dealing with a lot of data. The data was used for training machine, and the machine can predict the new cases by looking at what the previous data was telling. So that is also called computer vision. So the computer can see through the data. So if you had an app that could scan a mole on your skin, it would have tell you to go to doctor or not. And when it says it not, it was more accurate than human. So that is predictive discriminative AI. It is a great progress. NHS has implemented it in multiple occasions for multiple things, including predicting the heart failure. But then in 2020, something new came along, a new type of AI called generative AI. And generative AI can create content that could be audio, video, or text. When we are dealing with text, we usually refer to a type of generative AI that is called large language models. So when we are talking about large language models, we are talking about a type of AI which is generative AI. It's a subset of generative AI. So that is the new part. All AIs are not the same. And the predictive and discriminative AI is completely settled now in the healthcare, in the research, and people are using it frequently for diagnosis, prediction, and even for treatment decisions in personalized medicine, like in cancer treatment. The second confusion that people have, other than the typology of the AI, the two major type, for decades we've been told that AI is unable to do some things like making ethical decisions, or making causation or causal inference, and things like that. And we've been telling, people have made movies about that how the rule-based robots are taking over the world because they cannot make ethical decisions and all of that. But then in 2020, we have a new type of AI that actually can do things. So the things that we used to tell people for decades that AI can't do, now they actually can do some of them. And that has caused confusion because it is not easy to clear 3 decades of what we've told people. And then the technologies are not using one type of AI. When you are using your phone or when you are using even ChatGPT or Copilot, you are not just dealing with one type of AI. They usually are using multiple ways of automation, multiple types of AI and tools. So be aware that in most cases it is not easy to detect, but we need to try to know what is behind the programs when we are using it. So these 3 are very important to remember. And then about the large language models. So the large language models, a type of generative AI that are new, what they can do, they can make sense. They can create a text that makes sense. They can understand the context. They can do causal reasoning. They can be cultural, ethical aware. And there are other things that they can do, even emotional intelligence. People have started confiding in AI, and when ChatGPT just disappeared for a few months, some people were upset because they said that we lost our best friend. So it was helping people, saving people with mental health problems. So it already shows that it's a new type of beast that we are dealing with, and it can actually help you make ethical decisions as well. So this is a new type of AI. What it does, it just predicts what word is going to appear from the other. So they are not really intelligent. They are just reading the text. They have read a lot of text, so they are good writers. If you want to become a good writer, you need to read a lot, and large language models have been trained on a lot of literature. So they are not intelligent. They give the answer to your questions based on the probability and predicting what word is going to appear after this word. The things that they can't do, large language models, is fast information retrieval, statistical pattern recognition, consistent rule application, correlation analysis, and extraction on scale. What is funny is that the AI that we had before 2020 is capable of doing them. And the AI that we have got after 2020, large language models, they cannot do. So they are complementary. So if we could merge them together, we are going to have powerful tools. And there are things that large language models are not good at, but they can be pushed, they can be trained, they can be instructed to do. One of them is purpose-driven inquiry and then critical verification. The ones that I have put in bold font are the ones that we care a lot for systematic reviews. And at least 3 of the ones that I put there, large language models are not good at. So the first one is searching. We really need to do a comprehensive search for systematic reviews. The second is screening, consistent rule application, and data extraction, which is the last one. So these 3 large language models are not good at. So we are trying really hard to use them when we are using large language models in systematic reviews. But there are 2 aspects that we are working on it, and one is purpose-driven inquiry, and the second one, critical verification. And then there are also myths and confusions about the systematic reviews that you need to be aware of. One is that all systematic reviews are fine. As long as you run a search, systematic search, and you look at the literature and then you organize the results, you've done a systematic review. That is not true. We have different types of evidence synthesis that follow systematic reviewing. I will show you. And then some people say that using AI in systematic reviews is new. It is not. We've been using predictive discriminative AI for over 15 years in systematic reviews. And it is said that AI can do systematic reviews. I mean, if you look at, in YouTube, there are people saying that how to do systematic review with Elicit, how to do systematic review with that tool or this tool. None of the tools so far can do, none of the AI, large language models. We don't have any AI tool that can do a systematic review. They can support stages of systematic reviews with human involvement, but they cannot do a systematic review. And then the last one, the confusion is that people say that doing a systematic review is easy. It is not. It requires time, human resources, and sometimes monetary resources or funding. So, we could discuss a lot about why this confusions exist. But I'm going to move on to the main one. So what is a systematic review? Systematic review is a type of literature review that starts with a research question and follows the research steps, which is you have a research question, you collect data, you analyze data, and then you answer that question. So it is not like a narrative traditional review that you could write it on your own. One person can do it, and you can start and finish it wherever you want. So we start a systematic review of the research question. We do some scoping searches. We look around to see if there are enough literature. If there are enough literature, we say, let's go ahead. We could go ahead to the next stage. If there are a lot of literature, we could modify our questions to make it fit in our resources that we have, which is time and the human resources. And sometimes there is no literature at all, or there is a lot of literature, so one may give up. Anyhow, if you decide to go ahead, you could write a protocol and you could register and publish it. Even if you decide not to go ahead, you can still register and publish your protocol. And protocol is telling you what to do and how to do stage by stage. It is very important. The protocol is 50% of systematic review. If you write it very well, it will save you a lot of time. And then based on the protocol, you proceed with searching multiple databases. You design search strategies, you run the searches. The search strategies should be reproducible. And then you screen the search results using an existing program. It could be Rayyan, Covidence, or many other programs that exist for screening. And then you move to data extraction. So for the screening and data extraction, we usually involve two people. So screening has two stages. First is title and abstract screening. The second stage is full text screening. And then it comes to data extraction. And data extraction could also involve assessment of risk of bias, which is checking the quality of included studies. And in this screening and data extraction, we usually involve two human beings. So if there is any error, the inconsistency, they could check each other's work. And if there's conflict, they could resolve it or ask a third reviewer, who is usually a senior one, for help. So we involve two people, and that is the gold standard for doing a systematic review. And then when you've done data extraction, you could either end up with summarizing the results because they are heterogeneous. You could do meta-analysis if there is homogeneous data, that you could run analysis of quantitative data. And if you are dealing with qualitative data, then you could do meta-synthesis. And finally, you write a report. And most systematic reviews end there. But because as soon as you finish the search, new studies may merge. And new studies will be published. There will be new results coming next year, the year after. Some of the systematic reviews become living systematic reviews, so they keep updating frequently. So this process is called systematic reviewing. But it is not always like that. So sometimes you go ahead and do the searches. Screening is done by two people. In data extraction, you extract basic information that you could provide it as a figure, a map of what literature are about. So you could say that we looked at the conditions related to psoriasis. The interventions were phototherapy, there was systemics, there was combination of both, and you present it as a figure. So you don't do meta-analysis, you don't do assessment of risk of bias. Is it still called systematic review? What if you don't involve a meta-analysis? What if you summarize the text and do the risk of bias? Is it still called systematic review? So that's why, depending on how we go ahead, we will have different types of evidence synthesis. So just because you follow the process of systematic reviewing, it doesn't mean the final product will be called a systematic review. It can be called a systematic review, scoping review, mapping review, evidence gap and map. So those are usually called big picture reviews. So those three that I've highlighted on top as scoping, mapping, evidence gap map. And then depending on the mode of the review, if you do it rapidly, it's called rapid review. If it is going to be updated frequently, like every month or every 3 months, they are called living systematic reviews. And then based on the type of the studies that you involve, it could be qualitative review, mixed method reviews, meta-analysis. Depending on the study designs that you involve, they could be called integrative review that includes all the study designs, umbrella reviews that include only systematic reviews. So umbrella review is systematic review of other systematic reviews. It could be a realist review. So the realist reviews have a systematic review component, but they also have a qualitative component that involves talking to experts and patients. And then depending on the organizations that you are doing the review for, they could be called Cochrane review, Camper review, JBI. Depending on your question type, they could be different. And then depending on other purposes that exist. So we have state-of-the-art review, which is usually used for the regulatory purposes, and also targeted literature review that actually has no meaning, but it exists. So it is any type of literature review can be called targeted literature review because they are targeting something like a question, but people keep making up stuff sometimes. So these are the typology of reviews. So we have systematic reviewing as a process and systematic review as a product. Most of the time when people say that we are doing a systematic review, they don't mean that they are doing a systematic review. They mean that we are following a systematic reviewing process, but the end product may be something else than systematic review. And this discrimination is important. So the first stage in the systematic review is protocol development, that starts with finding a good research question. Large language models can help. So there are at least 2 studies showing that you could ask for large language models to give you idea of unpublished systematic reviews. I've also put the prompt in there from Balel's study. Some people have used large language models for finding questions that have not been answered or they are priority for the guideline development. So those are good uses of large language models and innovative uses as well. So you could use it in that way as well if you are looking for the ideas for systematic reviews. For searching, there are certain things that large language models can do. For example, finding relevant free text term for designing your search strategy, designing basic Boolean logic, and then translation of the syntax to multiple databases, because each database have different syntax for running the searches. And in this case, you need a search expert like a librarian or information specialist to check the output. Large language model can provide feedback on the search strategy that you have designed or your librarian have designed. And they are good at detecting some of the errors or making some suggestions. For finding some relevant papers rapidly or exploratory search, there are tools that are using large language models alongside other types of AI, like machine learning, different types of machine learning. And I recommend you to have a look at these 5 tools that I've put here. They are very good at exploratory searching. The first one, surprisingly, is good. So you could ask, it acts as a reference library, and you ask a question, it comes back to you and asks a question about your question. And then after 1 or 2 rounds of this reference interview that reference librarians usually do, they go ahead and try to find the literature and summarize it for you. So they run the search, they screen the results, they summarize it, which is sort of good for scoping, not a systematic review. And it takes 5 to 6 minutes until they do and finish the work. It's a very useful tool. The second one is for finding the consensus in the literature when there is lack of consensus on a topic or controversy. Elicit, Cite, and the Scholarcy are also good tools for searching. Some people even use Elicit for data extraction as well. But I would recommend you, if you have time, play with these 5 tools for finding some relevant papers. They never replace the rigorous systematic reviewing that we have. They are good for exploratory searching. And then machine learning based technologies like ASReviewer can be used for updating the search results, for updating systematic reviews, and they are very good at it. While there is no AI technology to be good at designing and running searches in a way that we could trust, ASReviewer can use machine learning and update the searches that you have already done and to find the relevant literature from a big database called OpenAlex. So AI actually is very good at updating search results if you have access and can use it. ASReviewer is not free, of course. And then there are things that we cannot use large language models. in searching. One is that they are not bibliographic databases, so asking them that give me the papers about this and that is not good, even though they are using RAG, so they could be connected to other sources. So the tools that I showed you on top, some of them are using RAG or retrieval augmented generation, which uses the large language capabilities only on a specific collection. So you could say that use your capability just for this, not going through entire internet, just use your capabilities for this PDF or for this dataset or for this database. And that is called RAG. And some of the large language models use that, but even using that, they cannot do the database searching, and they are not good for searching at all. And one reason that we cannot do that, you need to access to paid databases like Embase for systematic reviews, and large language models can't do that, and I don't think that Elsevier would ever allow them to access that database. And then the final search strategy design is not something that you would expect from large language models. Always you need a librarian or information specialist to check it. So after running the searches, you come to the title and abstract screening. We have established AI, machine learning, that helps you during screening. It's called a relevancy ranking, and it already has been implemented in Rayyan and Covidence. So as you screen, the machine learns from you. So you are the machine teacher, machine learns from you. And based on that learning, shows you the most relevant records on top so you can screen. Or you could do other way around and ask the ranking to show you the most irrelevant ones on top so you could exclude them rapidly. So there is an advanced way of doing it. It is called priority screening, that you could actually train some of these programs that I've listed here, like ASReview, Distilleries, or ASReview, that after a while of screening, it shows you a graph, a progress graph, that shows that actually as you continue screening, you are not including any new records. That is the point that you can stop, or at least one of the screening reviewers can stop, and only one person can continue the rest of the documents, because highly likely all of them will be excluded. It's called priority screening. There are other programs that you could use for priority screening, like Rayyan and Covidence, but it is not easy to know when to stop in them. While ASReview, Distiller, SR, and ASReview would show you the graph that will guide you when to stop. And please consider in title and abstract screening, it is not easy even for the humans to make decision on some of the records, leave alone the AI. And I will show you an example. It is not recommended to use large language model for screening of records without a human check, because there is no way that you would know that they have done it correctly without checking it. But also they cannot follow the procedure that we have, like two people screening and checking their conflicts. And it could be dangerous if there is a lazy researcher who wants to just do it rapidly, just uploading a file there and large language model giving an output that these are relevant, and then trusting it. So there is a danger there, because these systems, ChatGPT or Copilot, have not been designed based on the workflow that we have for systematic review. They are general tools. So an example of the output that we get from the databases. Clinicaltrials.gov is a registry of clinical trials, and the output that you get is very important for the AI. So because we have a rule called garbage in, garbage out. So if your input file is horrible, you cannot expect a miracle from AI. It doesn't matter if you're using machine learning or large language models. So if you export the results as RIS format in clinicaltrials.gov, what you get is going to be just a title that is very relevant. So in left-hand side, if you look at what you get, is only the title. But if you export it as CSV format, you get a lot of information. So it is very important to know that the input file has high quality records with a lot of information. And most of the AIs have been trained on big chunk of text, so they could actually do a screening better with big chunk of text. So this is Rayyan, that is using predictive discriminative AI. It has been using it for over 10 years. So I uploaded results and screened it, and it gave me relevancy ranking. I ranked it, and based on that rank, I screened it. There's a record that is obviously has got just title, because I got it from clinicaltrials.gov by mistake as RIS format, and it has only title, no abstract. And I was looking for randomized controlled trials of schizophrenia. This is a randomized controlled trial of schizophrenia. It is obvious from title, but AI, predictive AI, cannot make a decision because there is no abstract. So that is one of the cases. Large language model would make a good decision on this, the right decision. But it will mess up other things. So each one of them have their own advantages and disadvantages. So based on this rating, it says that I cannot decide if it is relevant or not. But as a relevancy ranking that exists in Rayyan, and I recommend you to use it. After a few screening, you could say compute rating, and it will give you this rating. This rating also exists in Covidence. After screening a bit, you could sort the records based on most relevant and screen the most relevant ones on top. That will help you to identify how many records are relevant and plan your systematic review. But you don't know when to stop. That is the thing. And you will have to screen all of the records, both in Rayyan and Covidence. This is ASReview, and this is what I was telling you about. That's the progress graph. So if you randomly screen the results, you have to screen and include. You are screening, there is a number of records screened, number included. You screen include, and it's like the stairs that you go, and you have to screen 4,800 to include all of the relevant records. If you use a priority screening and tell machine that learns from your decisions and show you the relevant records on top, that is what happens here. Then after probably 600, you could have stopped. And one reviewer can check and exclude the rest. So that's how much resources it could have saved if you were using priority screening and relevancy ranking. It's a huge time saving. If you know how to use it, so this tool is free, ASReview is free, Rayyan is free, Covidence is not. So it's very important to know that these features exist and you could use them. Even PRIMSA 2020, which is the reporting guidelines, allows us to use the priority screening. It says record marked as ineligible by automation tools. And I will show you when you can use it properly. If you are in Covidence and you are working on a systematic review of randomized controlled trials, when setting up the project, it asks you a question. And that is tag references reporting on RCTs. If you tick that, it will tag the RCTs. It will automatically detect the randomized controlled trials and tag them for you. You can also tick a box that remove references reported on non-randomized controlled trials before screening automatically. That is AI. That is discriminative AI. And we used it in a real review, and it says that there is a duplicate, and then it says 2,400 automatically marked as ineligible, and if I go inside the records to screen, it will mark some of them as RCT already. So these features already exist and are being used. I think in the last 3 years, we have had these features and we've been using this in Covidence. Very useful. And Covidence recently actually implemented large language model in the next stages as well. For the report screening, actually large language models are doing well because they have now access to full text rather than just title or title and abstract. And they do a good job with full text screening. Obviously, if you want them to make sure that they are doing it correctly, ask them to provide the quote from the text for reason for including or excluding the report. And that way, it's less likely to make error, but you should always rely on human as the final reviewer. For assessment of risk of bias, they cannot assess risk of bias, but they could provide all the information needed for you to make the final decision, which is great. If they provide anything, you could always ask that why. Give me a quote of why you decided that it is low risk or high risk. And then they shouldn't be the final judge of the risk of bias. Please consider that risk of bias may need more than one PDF. If you are assessing the risk of bias for reporting bias, the authors may have published a protocol or registered it in clinical trials and then published the paper separately. So there are two separate things. And then it is not possible to assess it without having two of them as one PDF or in one place. So that is something to consider. Also, to assess the risk of bias, you may need more information from different parts of the same PDF or more than one PDF, because one study may have multiple papers published from it, and you may need all of that. So that's something to consider. If you want to rapidly have a look at discriminative AI or RobotReviewer that existed for about 10 years, how it does the risk of bias assessment compared to Copilot and compared to PICO portal rapidly, what we will see is that, so this is RobotReviewer. It is a free tool, and it can do the assessment of risk of bias for randomized controlled trials based on the Cochrane's risk of bias tool version 1. What you do, you upload a PDF, and then it starts thinking, and it says that how much is done. At the same time, I'm going to upload it to Copilot, which is using the one that I'm using here, uses GPT-4. I say that this is the PDF. Assess risk of bias for this RCT using Cochrane ROB1 tool. I could actually say tabulate to be more specific. So I'm giving it to, so RobotReviewer is done. It assesses the risk of bias for only 4 domains because the other ones requires human, and it says that a random sequence is low risk. The others are questionable or unsure. And let's look at Copilot GPT-4. It also says it is low risk, unclear risk. But also when it comes to blinding, it says that it is high risk. It says that the participants were not blinded. I don't think it was possible to do the blinding because one of them had sun exposure, the other one didn't have it. So I wouldn't call it high risk, but it does. So that's why human check is required. And then unclear risk. So in one case, they don't agree, the discriminative AI and generative AI. They don't agree. So and then I'm gonna show you another example from PICO portal. PICO portal is a tool for systematic reviews that has implemented large language model in a good way for using for to help in risk of bias assessment. So what it does is that you upload the PDF, you select the tool, it opens the PDF automatically, it scrolls down to the section that is relevant, it highlights the section that is relevant, and it makes a default, well, initial judgment that you could change. So all of that happens automatically. And if you want to do all of that manually, you have to open the PDF, Control F or scroll, and then find it and make decision. It has already done all of it. The only thing you need to do is to check if it is correct and then change it if needed. And consider that one section highlighted as attention map, it doesn't mean that it contains all the information. There may be more information about randomization in other sections of the report. But this is a good implementation of large language model inside an automation tool that already has been designed for systematic reviews. So, and that is the best way to use the AI, using it within the existing tools. For data extraction, as I mentioned, when AI has PDF, full text, they are doing well. They are so good that they could even extract data from figures or even scanned images, PDFs. Not always accurately if you check, but sometimes if the quality of the figure is good, quality of PDF is good, they could extract even from figures and scanned PDFs. It is great. For translation of good quality PDFs, they are working amazingly. But if the quality is scanned, it's old PDF, you need to be very careful, because when they cannot do it correctly, they start guessing the words and guessing the meaning. And then when not to use it in data extraction is just relying it that they are doing it correctly without checking. No, you shouldn't do that. And for risk of bias assessment and even for data extraction, you may need more than one PDF because one study may have published multiple papers and data may be spread. And then for data extraction, you may also need information from, as I mentioned, from multiple PDFs, because that's what people do to get more papers on their CV. So one thing that discriminative AI had problem with was that we had 2 columns, and many people, I mean, AI didn't know that the journal papers have 2, or in case of Lancet, 3, 4, 5 columns. So if it, when it was reading it, it was reading it as a line, like don't dead open inside, because that is the line, and that is how AI used to read the line, while it should have read that don't open dead inside. And as a screenshot from Walking Dead, that you could easily misinterpret just by the format of the PDF. But the generative AI has become better than discriminative AI in this case, and could recognize the columns and read it correctly. But it's a good example that when discriminative AI was struggling and generative AI is not. So tips for the data extraction, because I think many people are going to use large language models for data extraction. Use specific instructions like tabulate, extract, rather than describe, collect. Quality of PDF is important. Large language models may not recognize discrepancies. So I had a PDF that the authors reported mean and standard deviation for the same group in the same timeline, differently in abstract and in the table. So it was the author's error. And in those cases, large language models cannot detect it, only human can. If your PDF has multiple groups of patients, multiple intervention groups, or multiple studies within one published paper, that sometimes people do, it will confuse large language model. Consider factored cognition. So rather than asking AI to do everything at once for you, give them bite-sized requests, tiny tasks to do it. That way it works. It works better with one PDF rather than multiple PDFs. I've tried it. I tried one by one and it worked perfectly. I uploaded 5 PDFs, and what happened with the Copilot, it created the healthcare conditions that didn't even exist inside the PDF. So it says that each one of them is about a condition, and I opened the PDF and it wasn't even there. So it created 5 healthcare conditions that wasn't even reported in the PDFs. So it is very important to know their limits. They are not good with the data in figures, and they cannot extract numerical values all the time correctly, or tables that are in image rather than in a way that you could select it. And even though many of them can read scanned versions and scanned images, they are not necessarily good at doing it accurately. Sometimes that you ask for data from results and methods, when they cannot find it, they try hard and they find the data from discussion and introduction. Like if you are looking for the prevalence from the results, they may find the prevalence from the introduction, which is not what you are looking for. And always use the large language models using your organizational login, like NHS login and university login, because they are copyright compliant and they are not using your data for training. The free ones are free because you are paying with your data and the files that you are uploading. They are using it for training. So be very careful on what version you are using. Almost all of them now are using RAG by default, which wasn't the case like a year or 2 years ago when they started. Now all of them are using retrieval augmented generation, which reduces the errors massively. And then the higher versions are not necessarily better. That's something to remember. For meta-analysis, you can use large language models, but we've got better tools. I mean, we've got better tools that can do meta-analysis or statistical analysis definitely correctly. Why should we rely on something that may have errors when we have packages? But still, I have run meta-analysis in Copilot and it's done it correctly, even though it has problems with visualization, which is one of the reasons I'm not using it for meta-analysis, because we need beautiful forest plots. And they are not good at creating that visuals that you could get from R or from Review Manager or from Stata. And they can convert the summary statistics to each other. So if you give IQR and median and ask for mean and standard deviation, they can't do that. And always ask for the formula that they used or how they did it, to show how they did it, because that makes them less likely to make an error. This is the meta-analysis that I asked. So I gave 2 studies and asked GPT-4 in Copilot to do a meta-analysis. It did it correctly. It gave me the risk ratio correctly. But what it does is that there is a 1, 2, 3 in the left-hand side that I have no idea why they are. You don't need the numbers there. And then at the bottom says that each line represents a study risk ratio. And then finally says that the red marker at the bottom shows the summary effect size. There is no red marker at the bottom. There is on top, and it shows it correctly actually, but it is not on the bottom. It is on the top. So that is, you can do meta-analysis as well. For assessing the certainty of evidence, which we use for the guidelines a lot, it can be used for certain domains, but human check is needed. And then when using AI, any type of AI, consider that the garbage in, garbage out, and garbage in the input could be human expertise and decisions. So if I'm not expert in the topic and doing a screening, I'm going to mess up because I make bad decisions, and then that messes the AI that learns from me, the machine that learns from me. The quality of records and the PDFs, reports, is important. In case of large language model, the quality of prompt or instruction that you are writing is also important. It's part of input. And then there is one inevitable condition for using AI. Humans must be involved all the time. And there should be zero trust. You should never trust that machine is going to do a great job. Always you need to check the work. And then you need to document and report the way that you used AI in a reproducible way. If you use the prompt, you should say what prompt was that, what version of AI you used, what platform you used, GPT-4 in Copilot on this date using this prompt, and this is the result that I got. So it's very important to report it in a way that we do our best to be correct, even though many people will not do that, but we will do our best. Follow the existing practice guidelines like PRIMSA, Cochrane Handbook when conducting and reporting your work. Choose a specific tool. Don't always go for the GPT for everything. There are specific tools. I just gave you a few of the tools. For screening, use Covidence, Rayyan, and other tools. For exploratory searches, use Undermined. It is good. Try to know what are the existing tools that have been designed for a specific purpose. And there are research that shows that, large language model works for a screening title and abstract, and we did it. And when they say we, there are 20 people have conducted a research that took 12 months to just say that it works. And in real world, not only that we don't have 20 people a month, but also that the AI that they've used has changed. So it may not work. So whatever you see in the research, it doesn't mean that it's going to work for you just because it works in the research. And if you want the LLM to have a better output, assign a role or context that helps LLM to see what you mean, what is the context of the task that you are requesting. Continue using AI features that exist within the systematic review tools like Rayyan, Covidence, API-Reviewer, Distiller, SR, ASReview, all of these tools. I will give you the directory of all these tools at the end. Why? Because these tools have been designed specifically for systematic reviews. They follow the best practice guidelines, and human check always is needed. And human is the responsible. If AI makes an error in your work, you are responsible, not AI, not LLM. Always you are responsible. And if you are using large language models independently outside these programs, use them as initial reviewer or assistant, not the senior and final caller. And it is very important to ask for the quotes from the text when you are asking questions or extracting risk of bias to make sure that it does it correctly. If you are doing any calculation, ask for the formula. That way it reduces the error, and repeat the same task in multiple time points or multiple LLMs to check the reproducibility and repeatability. That makes them reliable. You can control the large language model that you are using. Either you are using Copilot, go to the setting, or you are using GPT, ChatGPT, organizational version, go to the setting. You have options to control. There are settings that you could also implement in prompts, like the temperature setting. Temperature in AI means the randomness and the creativity. So when you set the temperature to 0.2, you ask AI to be very conservative as much as possible. When you put it on 1.5, you give creativity to write a novel from a scientific paper. So that is very important to know that you have options to control as much as possible. They are challenging because using AIs in research, because they are not reproducible, they provide creative answers. They frequently get updated with new versions, and the old versions become inaccessible. And with different prompts, you will get different answers. That is also the variation. We need to have standard prompts or validated prompts that should work all the time, but we don't have it. And the research that have been done, validation research, have used different designs, different outcome measures, different reference standards. So we cannot actually pull them together to see if they work or not, because they are so different. Some of them say it works, some of them don't. If we systematically review them, they are so diverse that we couldn't make a conclusion. Lack of transparency on data source that they've used for training. They don't say what the data they've used, because they know that some of them were not right. They shouldn't have done it, but they have. So they are hiding it. The lack of transparency limits our use of AI, like generative AI, independent ones in research. There is contamination bias that what if the validation process that we are going through, we are using retrospective systematic reviews, for example, asking AI, what papers should be included in this systematic review? Obviously, because the systematic review is already published, AI can cheat and tell you. It doesn't mean that it works well. So there should be prospective design. And then there is risks of using LLM. One is that some people are lazy, they don't have time, they are busy. So it is likely that they ask AI to do something and they check 1 or 2 points and say that, yeah, it looks all right, I'm not going to check the rest. That is the danger. The second is that if we use large language models a lot and do everything with them, we will have a loss of skill. We want our students to know critical thinking, and risk of bias assessment does that, helps them to learn it. If AI is going to do that, they are going to lack that skill, which is an important skill for life and career. There's a problem with intellectual property. Uploading PDFs in free versions of large language models is breach of copyright. There could be unintentional plagiarism bias that we cannot detect it easily. The references that are providing for the text do not contain the information that they have cited. I mean, it provides an answer and it has references you could see in Google, but then you go to the reference or link and you couldn't find that information in there. That is a danger. And always use the institutional version. I couldn't emphasize enough on this. Because we don't have a guidance, many people go to YouTube. That could be misleading. Data privacy is important if you are uploading patient data for clinical or research setting, research purposes. There is environmental impact of how using it, the impact on the carbon footprint. Fortunately, we have now Edge AI that uses your own device only for running anything actually, which is great progress. And there are biases, and there is cybersecurity issue that sometimes people can use these models to hack into the NHS system or your organizational system and access data that they are not supposed to. There are ways to do that. Golden rule: if you cannot do something, don't ever ask large language model to do it for you, because they will do it, but you will never know if they have done it correctly. And then you are always responsible. Whatever goes wrong, you are responsible, not large language model, so double check. So some references and some things to check. And at the end, I put the systematic review toolbox that contains all of the tools that you need to do a systematic review: automation tools, machine learning tools, large language model tools that you could use, and some guidance that I would recommend you to check. For the future developments, we hope that AI literacy course would become mandatory in all organizations soon. If you want to keep up on this topic, I have created a free private newsletter, so I cannot see your names. You will not receive advertisement. You could register and receive weekly updates on Sunday morning on new publications. I have a YouTube channel that posts videos, including this one, hopefully. And then there is a map of all the publications related to automation of systematic reviews. So before you go to your lunch break, we have 7 minutes. I appreciate that you bared with me for 50 minutes in a row, and I'm happy to take any questions.
Thanks so much. That's really, really interesting talk, and really good to have some practical tips on this topic. You mentioned that there's already some people using AI in reviews, and it sounds like this space is evolving really quickly. So I was just wondering if you had any tips for, as someone that would read a paper or appraise a paper or kind of peer review a systematic review, how do you kind of appraise AI use in those settings, and how do you compare the use of AI versus a human doing the same thing? Is there something you do differently to normal in appraising AI?
There are multiple ways of doing it. Because that was one of the problems that we have with using large language models, because we don't have a standard way of evaluating them. So there are about 600 papers published. I have a collection of them, and each one of them do it differently. And that is our problem, that we cannot tell people how to evaluate them, because there is no reference standard or a way that everyone agrees that we need to evaluate. So my suggestion, the safest suggestion, is that you do the work and ask AI to check or feedback on your work, whatever you are doing. That is the safest option, because you've done it. You've done data extraction, risk of bias. You've seen the paper. You've critically thinking is done there. So AI would give you extra points. Another option, which is less safe but still safe, is that you do it independently. AI does it independently. You do it independently, and you check your answer against the AIs. So that is the second approach that you could take. The third one is that AI does it and you check it. That is not safe. Because in my experience, people are lazy and busy, so they will not check it thoroughly if that is done. And the worst one is that you just ask one or two AI to do it, and then you check their answers without looking at the full text. So that is the worst one, because some people say that, okay, I will use large language model GPT as reviewer number 1, and I will use Cloud as the reviewer number 2. That way I've done a systematic review because I have 2 reviewers now. So we don't have any standard. We could only try to be on the safe side, which is you do the work, ask AI checking it, or do it independently and check both the work done.
I just wanted to ask about the living systematic reviews. So
Yes.
Because they keep getting updated, do they get cited in research, and does the conclusion change continuously?
So there are 2 things happening in living systematic reviews. One is the update searches that could be set to weekly, monthly, or 3 monthly. Usually it is recommended that for living systematic reviews, it should be less than 3 monthly. So monthly is recommended. So when the update search is done, not all of the update searches end up to updating systematic review. So in most cases, we keep running these update searches and we find papers, but we know that they are not papers that are going to change the conclusion. That's why we don't update it. But as soon as there is something that is really important and it changes the conclusion or certainty of evidence, then we update it. And yes, when we update it, it becomes a new publication. It gets a new DOI. We recommend that anyone who has made any recommendation based on the previous version to change it. We couldn't push them to do that. But yes, the living systematic reviews get updated, their results get updated, and their conclusion. I hope it answers your question.
AI is at the moment how it's being used. Has there been much evidence of benefit? So in terms of, has there been research to show that there has been an improvement in kind of time savings and how that matches to kind of quality of review, and it's kind of doing, is there anything like that out there?
Yes. For discriminative and predictive AI, we have evidence that for using it for priority screening and also for relevancy ranking, yes, we have evidence that shows that it saves time. And specifically the classifiers, randomized controlled trials classifier that I showed you in the Covidence, it is 99.9% accurate because it has been trained on Cochrane's database, central database. It could easily detect randomized controlled trials, which is saving a lot of time for people rather than screening everything one by one. I just showed you that 2,400, that is like 2.5 days of your, and 2 reviews, it's going to be 5 days, saved. So we have published evidence on that. For the large language models, we have a lot of papers published that claim that they save time in the research setting. But in reality, because we don't know the evaluation that they've done, how reproducible it is, and they haven't followed any standard, they have designed and run it in a way that they wanted, we couldn't say that. So what I can say is that using it as assistant, and that would help a lot. So, I mean, we already use Microsoft Office. We already use Google Scholar. I mean, sometimes even we don't report that we use Google Scholar to find a few relevant papers. We use it as assistant. They are not replacing us. So as long as they have been used within the existing automation programs or used as assistant alongside the work that human is leading, I think they are safe to use. And as long as we remember that we are responsible for the output. Hopefully you have learned something, and if you haven't, I apologize, because it was too much content to deliver in short time. And I hope that you will start using AI and enjoy using it and get fascinated by where we are now.
Farhad?
Yes.
So just quickly, so the PDF that you showed at the end with contact details and suggestions for different models we can use, will that be sent later, or your YouTube channel, and then
yes, the slides. I'm going to send the slides, yes, and it will be shared with you, absolutely. And the recording is going to be, yes, on YouTube as well. So.
Great. Okay. Many thanks.
Thank you.